Question 20. The word strengthen says we're doing a strengthen question, which means that we have to support the argument's assumptions. But to support them, we need to know what they are, and we won't know that unless we know the argument's conclusion and its evidence. The conclusion in this argument is helpfully flagged for us by the thus. Thus, glutamate leaking from damaged or oxygen-starved nerve cells is a cause of long-term brain damage resulting from strokes. Now, if the word glutamate frightens you, in your head just use G, so G leaking from the brain. Science is never important for the actual details of the science or the fancy names. It's just the logical relationships. Now, we're given some evidence to believe that glutamate is a cause of long-term brain damage from strokes. A study. So we did a recent study of stroke patients, and those who had continuing problems with their nerve cells in their brain after their strokes also exhibited the highest levels of the protein glutamate in their blood. So the people who kept having damage after the stroke to their brains had the highest level of glutamate in their blood. And then the second piece of information, glutamate, which is a neurotransmitter, can kill surrounding nerve cells if it leaks from damaged or oxygen-starved nerve cells. That's not a terrible argument. Glutamate causes brain damage that comes from strokes because the people who are the most damaged tend to have the most glutamate in their blood. It is a causal argument, so it has the standard causal assumptions. So they're saying glutamate causes damage, so we have to believe that it's not a coincidence that the glutamate is just hanging out in their blood suspiciously. There's nothing else going on that could be responsible for the brain damage, so nothing other than the glutamate that could cause that damage. And the relationship can't be reversed, or we can't have reversed causality. In other words, it's not the brain damage that causes the glutamate to show up in the blood, but rather the glutamate that causes the brain damage. Now, this argument also has another assumption, so it's not just the causal assumptions, because of the way the conclusion is phrased. So it's not just glutamate, but rather glutamate leaking from damaged cells. And note, the glutamate that they give us in the evidence is glutamate that's in the blood. So for this argument to work, we also have to believe that the glutamate that's in the blood is the glutamate that leaked out of nerve cells. If that blood glutamate never gets into your brain, well then it can't really cause the damage. So we have to believe that the two glutamates are one and the same. The correct answer will help one of these assumptions. It will bolster it. So let's see what we have in the answers. Answer choice A would actually hurt the argument because it would suggest the possibility that there could be other neurotransmitters that are causing the damage, because any neurotransmitter that leaks will damage nerve cells. We're trying to prove that it's glutamate. So A hurts the argument. B also hurts the argument because it puts a wide variety of weird stuff in the blood of stroke patients. So some of that weird stuff could be what's causing their brain damage, not glutamate. We don't want extra candidates for the damage. We want to narrow the candidates down to just glutamate. Answer choice C. This answer is tempting to a lot of people because it does seem to relate to that last assumption, but only seems. The argument doesn't require that there be nothing else leaking from the damaged nerve cells other than glutamate, just that the glutamate that we detected definitely traces back to the nerve cells. They could leak lots of things, as long as the things they're leaking are not known to hurt brain tissue. Glutamate, we already know, hurts brain tissue. Finding other things leaking is not a problem. Finding other things that damage nerve tissue would be a problem. Then answer choice D, well, this is pretty much directly stating that last assumption. Leaking from damaged or oxygen-starved nerve cells is the only possible source of glutamate in the blood. So the glutamate is the same glutamate, because that's the only place it could come from. So that supports that final assumption. It is our answer. E, it seems to be closing up a loophole, but it's not really a loophole that hurts the argument. If the damaged cells die as they leak glutamate, that'd actually be okay. That would speed up the damage to the brain. The more nerve cells that die, the better. I mean, the better for the argument. So we don't need to make sure that the nerve cells aren't dying as they leak. They could die as they leak and it'd be fine. So E is eliminating a loophole that's not really a loophole. It's not our answer. Answer choice D was the answer.